Imagine a darkness so absolute that the concept of light feels like a distant, fading memory. Out there, in the freezing expanse of interstellar space, over 24 billion kilometers away from the warmth of our sun, a piece of human history is slowly suffocating. It is not surrounded by the fiery chaos of a dying star or the violent gravity of a collapsing black hole. It is simply drifting through a silent, indifferent void, surrounded by nothing but the microscopic dust of the ancient cosmos and the terrifying emptiness of the heliopause. Out here, the temperature plunges to -255 degrees Celsius. In this frozen abyss, a solitary machine, a fragile construct of aluminum, gold, and silicon, is fighting a losing battle against the one enemy no engineering can defeat: time. Right now, as you listen to this, a faint whisper is traveling across the solar system. It takes more than 22 hours for this signal to reach Earth, moving at the absolute speed limit of the universe. By the time it washes over the massive parabolic dishes of our deep space network, it is impossibly weak. We are listening to a transmission that carries less than a billionth of a watt of power. It is a technological miracle that we can hear it at all, a testament to the ingenuity of a species that dared to hurl its eyes and ears into the great unknown. Yet, this whisper carries a grim diagnosis. The heart of this pioneer is failing. The radioactive decay of plutonium-238, the nuclear pulse that has kept it alive for nearly half a century, is inevitably winding down. It is not a sudden death. It is a slow, methodical starvation. To keep the transmitter alive, to ensure that this solitary voice can still cry out into the dark and be heard by its creators, a quiet and ruthless sacrifice is taking place. Deep within its ancient code, survival protocols are being executed. Instruments that have tasted the atmospheres of gas giants and mapped the rings of distant worlds are being systematically and permanently blinded. Heaters are being turned off, allowing the lethal cold of deep space to creep into its metallic veins. We are dismantling our greatest explorer, piece by piece, just to keep its mouth open for a few more years. If you seek the truth in the dark, and if you are drawn to the profound mysteries of our silent universe, subscribe and join us on this journey. We are listening to the fading pulse of our greatest explorer, but to truly comprehend the physics of its slow demise and the brutal reality of the environment it is drowning in, we must completely discard everything our terrestrial intuition tells us about distance, energy, and what it actually means to survive. To truly grasp the gravity of this slow, mechanical suffocation, we must first violently dismantle our own intuition. As terrestrial creatures, our brains are fundamentally hardwired by the environment we evolved in. We navigate a world defined by friction, atmospheric pressure, and immediate physical boundaries. When we throw an object, air resistance and gravity drag it to a halt. When we shine a light into the night, the beam is scattered by moisture, absorbed by the terrain, and quickly swallowed by the dark. We associate distance with exhaustion, and we implicitly believe that energy is something that physically pushes through space until it simply tires out and stops. But the cosmos does not operate on the logic of Earth. In the vacuum of the interstellar medium, things do not simply stop, they drift forever, and energy does not tire, it dilutes. The signal currently emanating from our distant probe is not fighting against friction or wind, it is fighting against the tyranny of geometry. In the 19th century, as scientists began to untangle the mysteries of the physical world, James Clerk Maxwell formulated the equations that govern electromagnetism. He revealed that light, radio waves, and X-rays are all manifestations of the same phenomenon, undulating through space at a constant, unbreakable speed. Following his theoretical groundwork, physicists began to understand the brutal mathematical reality of how this energy propagates. They realized that a transmitter does not fire a radio wave like a bullet from a gun, traveling in a straight, concentrated line. Instead, it expands outward like a sphere. This introduces us to the central villain of deep space communication, the inverse square law. The principle dictates that the intensity of an electromagnetic wave is inversely proportional to the square of the distance from its source. In the cold language of physics, this is expressed by the equation I equals P/4 pi asterisk R2. Here, the power of the transmitter is divided by the surface area of a continuously expanding sphere. As the signal leaves the spacecraft, the sphere of radio waves swells exponentially. By the time it has traveled 24 billion kilometers to reach our planet, the energy of the original transmission has been smeared across an area of space so unfathomably massive that the numbers lose all meaning to the human mind. Imagine standing in total darkness, engulfed in an infinitely dense fog, holding a tiny fading flashlight. You are trying to signal someone standing on the opposite side of the world. The light does not die because the fog kills it. The light dies because the sphere of its illumination stretches so thin that a single human eye can no longer detect the individual photons. The transmitter aboard the spacecraft operates on merely 20 watts of power. That is roughly the electrical output required to illuminate the small bulb inside your kitchen refrigerator. With that pathetic amount of energy, it must scream across a void so vast that sunlight itself is reduced to a meaningless, cold pinprick in the black sky. To catch this microscopic fraction of a watt, our civilization has constructed the Deep Space Network. We have built massive, 70-meter-wide parabolic dishes across the globe, nestled in the valleys of California, the outskirts of Madrid, and the scrublands of Canberra. These colossal structures are essentially giant mechanical ears, cupping the sky, listening with cryogenic receivers, cooled to near absolute zero, just to quiet the thermal noise of their own electrons. They are sweeping the heavens, trying to catch a fraction of a whisper against the deafening static of the cosmic microwave. Background radiation, the literal echoing hiss of the Big Bang itself. And yet, catching the signal is only the final act of the play. The true terror lies in how that 20-watt whisper is generated in the first place, out there in the freezing dark. Where this machine travels, solar panels are useless glass. The sun is too incredibly distant to offer any meaningful kinetic or electrical warmth. To survive the heliopause, an environment where temperatures plummet toward absolute zero, the engineers of the 1970s had to provide the spacecraft with its own internal, inescapable fire. They equipped it with a radioisotope thermoelectric generator. It is crucial to understand that this is not a nuclear reactor. It does not split atoms in a violent, controlled chain reaction like a power plant on Earth. Instead, it operates on a much quieter, far more somber principle of atomic decay. Deep within the dark chassis of the probe, isolated in protective graphite aeroshells, lie ceramic pellets of plutonium-238. This is an incredibly unstable, radioactive isotope. As the laws of quantum mechanics dictate, the nuclei of these plutonium atoms are constantly breaking apart, seeking a stable state. As they fracture, they violently eject alpha particles. These subatomic shrapnel pieces collide with the surrounding ceramic matrix, creating kinetic friction on a microscopic scale, which manifests as intense, glowing heat. This decaying heart literally glows red-hot in the middle of the frozen cosmic ocean. But heat alone is not electricity. To power the computers, the gyroscopes, and the vital transmitter, that thermal energy must be converted. This is achieved through the physics of the Seebeck effect. The engineers surrounded the dying plutonium with thermocouples devices made of two dissimilar metals joined together. When one end of this metallic junction is exposed to the searing heat of the plutonium, and the other end is exposed to the lethal -255 degrees Celsius cold of deep space, the extreme temperature differential forces electrons to flow. This flow of electrons is the lifeblood of the machine. It is the direct current that keeps the ghost in the machine awake. There are no moving parts, there are no pistons, no turbines, no gears to lubricate. It is a completely silent, solid-state extraction of energy from the death throes of an atom. It is an engineering masterpiece, but it is also a ticking clock governed by a mathematics that cannot be negotiated with, paused, or reversed. Radioactive decay is not a linear process. It is an exponential unwinding. It follows the precise, unforgiving mathematical function NT, Ne0, E, lambda visis, T, where the remaining quantity of the radioactive material depends on its original mass, the base of the natural logarithm, and a decay constant intrinsic to the isotope itself. Plutonium-238 has a half-life of 87.7 years. Every single second of every single day since the late 1970s, there has been slightly less plutonium in the core than the second before. The fire is dying. It is like an ember in a freezing, abandoned cabin. You have no more wood to throw on the hearth. You can only sit in the dark, watching the glow shift from bright orange to a dull, angry red, and finally to a dusty, encroaching gray. The tragedy of this power source is compounded by the harsh reality of material science. Not only is the nuclear fuel slowly starving, but the thermocouples themselves, the very metallic veins responsible for converting that heat into life, are degrading. Decades of relentless exposure to extreme radiation and severe temperature gradients have caused the microscopic crystalline structures of the metals to break down. Their efficiency is collapsing. As a result, the electrical output of the spacecraft drops by roughly 4 watts every single year. A slow, agonizing hemorrhage of power that no one on Earth can stop. Every year, the baseline required to keep the spacecraft functioning climbs closer to the failing threshold of the generator. Our terrestrial intuition assumes that when a machine breaks, it simply stops. A car runs out of gas and halts on the side of the road. A phone battery hits zero and the screen goes black. But out there, death is not a sudden curtain drop. It is a forced, agonizing triage, because the power is failing and the distance is perpetually expanding. We encounter the horrifying reality of cosmic latency. Imagine sitting at your computer in a completely empty, silent megacity at 3 in the morning. You send a message to a server located on the other side of the planet. You wait a fraction of a second, and the reply arrives. Now, scale that server latency to the dimensions of the solar system. The spacecraft is so far away that the light carrying our commands, traveling at nearly 300,000 kilometers per second, takes over 22 hours just to cross the void. When a flight controller at the Jet Propulsion Laboratory sends a command to the spacecraft, they are not communicating with a machine in the present. They are speaking to a ghost. The command leaves Earth, racing past the orbit of Mars, slicing through the asteroid belt, surging past the colossal magnetic storms of Jupiter and the icy rings of Saturn. It flies outward for almost an entire rotation of the Earth. By the time the digital instruction finally strikes the 3.7-meter high-gain antenna of the probe, the spacecraft has already physically drifted over 1 million kilometers deeper into the unknown. The machine processes the command, executes the code, and whispers its confirmation back into the dark. We must then wait another 22 hours for that reply to return. A simple round-trip conversation, a single digital handshake, takes nearly 2 entire days. In any crisis, in any critical failure, where a heater malfunctions or a gyroscope slips, the engineers on Earth are completely paralyzed by the speed of light. They must predict failures days before they happen. They are playing a game of chess where it takes 44 hours just to see if the opponent has moved a pawn. This immense latency, combined with the slowly starving nuclear battery, forces a cruel logic upon the mission to ensure that the 20-watt radio signal can still penetrate the 24 billion kilometers of dark space. The power must be constantly balanced. Every milliwatt of electricity is fought over. The computers need power to think. The gyroscopes need power to maintain the incredibly precise orientation of the antenna. If that antenna drifts by even a fraction of a degree, the radio beam will miss Earth completely, sweeping harmlessly into the black void, and the spacecraft will be lost to us forever. To maintain that perfect alignment, tiny thrusters must occasionally fire, releasing microscopic bursts of hydrazine gas. But hydrazine freezes. To keep the propellant liquid in the absolute zero of the interstellar medium, electric heaters are required. Heaters draw immense amounts of power that is no longer there. The engineers are trapped in an inescapable paradox of thermodynamics. You need power to keep the fuel warm, to keep the antenna pointed, to keep the radio transmitting. But the plutonium is fading, and the cold is creeping inward, inch by microscopic inch. Our earthly intuition fails us entirely here. We cannot fathom a machine that must willingly amputate its own senses just to keep its vocal cords functioning. We cannot intuitively process the concept of a solitary metal object entirely devoid of human presence, executing lines of code from a bygone era, quietly shutting off its own heaters, knowing that doing so will allow the freezing void to permanently claim its scientific instruments. It is a slow, cold suffocation happening right now in the deepest silence ever known. To understand the environment that is slowly killing this machine, we must physically map a boundary that is entirely invisible to the human eye. For the majority of human history, the architecture of our solar system was defined by the solid matter we could see reflecting the light of our local star. We charted the planets, the erratic orbits of comets, and the dense, rocky debris of the asteroid belt. We assumed that the domain of the sun ended where the last rock circled in the dark. But the sun is not merely a gravitational anchor. It is a terrifyingly violent thermonuclear engine, and it exhales. Every single second, the sun detonates millions of tons of hydrogen in a relentless fusion reaction, generating a maelstrom of magnetic fields and superheated plasma. This boiling corona cannot contain itself. It violently ejects a continuous blizzard of ionized particles, protons, and electrons traveling at 1 million kilometers per hour. This is the solar wind. For billions of years, this invisible gale has been blowing outward in every single direction, inflating a colossal magnetic bubble in the middle of the Milky Way galaxy. This bubble is called the heliosphere. It is the atmospheric shield that encapsulates the Earth, Mars, Jupiter, and all the outer planets, pushing back against the hostile, chaotic radiation of the broader galaxy. Inside this bubble, we are protected. We are shielded from the catastrophic cosmic rays born in the explosive deaths of ancient stars, but the solar wind cannot push outward forever. As it travels deeper into the void, the volume of the sphere it must fill expands, and the pressure of the outward flowing plasma drops. Eventually, it must collide with the interstellar medium, the ancient freezing soup of dust, gas, and radiation that fills the space between the stars. This collision is not a solid wall. It is a turbulent, chaotic, and invisible frontier of physics known as the heliopause. The mechanics of this boundary are governed by complex magnetohydrodynamics, the outward momentum of the solar plasma, defined by its dynamic pressure P_din equals ρ asterisk V2, where ρ represents the mass density of the particles and V, their velocity, gradually loses its dominance over the inward pressure of the surrounding galaxy. For decades, astrophysicists debated exactly where this theoretical shoreline existed. Some believed the spacecraft would hit it in the late 1990s, just past the orbit of Neptune. They were profoundly wrong. The bubble was vastly larger, and the journey to its edge was a terrifying lesson in the scale of the void. In August of 2012, after 35 years of continuous flight, something in the data abruptly shifted. The instruments aboard the spacecraft began to register a highly abnormal environment. The stream of solar particles that had steadily bombarded the machine since it left Earth suddenly plummeted. At the same time, the bombardment of high-energy galactic cosmic rays particles screaming in from the deep galaxy at nearly the speed of light spiked violently. The craft had pierced the membrane. It had crossed the heliopause and sailed into the true interstellar ocean. To measure this crossing, to actually prove that it had entered the space between the stars, the engineers relied on an incredibly delicate piece of machinery called the plasma wave subsystem. You must picture two slender antennas forming a V-shape extending from the body of the spacecraft. These are not cameras. They cannot see the stars. They are essentially electric field sensors designed to measure the minute fluctuations in the plasma environment. They listen to the vibrations of the void. The interstellar medium is not perfectly empty. A true, perfect vacuum is a mathematical abstraction that does not exist in nature. Even in the deepest, darkest trenches of interstellar space, there is matter. It is unimaginably sparse, perhaps only a single atom of hydrogen per cubic centimeter, alongside a ghostly mist of free electrons. Our terrestrial intuition cannot grasp a density this low. The air you are breathing right now contains roughly 20 quintillion molecules in every cubic centimeter. Space is empty to a degree that defies human comprehension, but that single atom per cubic centimeter is enough to carry a physical wave. When immense coronal mass ejections from our sun crash into the heliopause, they send shockwaves rippling out into the galactic plasma. These shockwaves cause the free electrons in the interstellar medium to oscillate. The plasma wave subsystem detects this oscillation. As the electrons vibrate, they generate a specific frequency, a pitch that the instruments can record. The frequency of this ringing plasma is directly proportional to the square root of the electron density. Governed by the precise plasma frequency equation, f underscore p equals 1/2 pi asterisk sqrtn underscore e asterisk e2m underscore e asterisk epsilon underscore 0. By capturing this faint, unearthly ringing, scientists on Earth could calculate exactly how dense the space around the probe was. The data returned was chilling. Inside the solar bubble, the density of the plasma was incredibly low and hot. But as the spacecraft pushed deeper into the interstellar medium, the pitch of the plasma wave increased. The density of the cold electrons was rising. The spacecraft was not flying into nothingness. It was flying into a thick, invisible, and ancient cosmic fog that had been undisturbed since the dawn of the galaxy. Consider the sheer mechanical audacity of this measurement. A machine built with the processing power of a digital alarm clock, holding an antenna made of aging metal, is flying through a darkness so complete that the sun is just a slightly brighter star behind it. It is bombarded by radiation that degrades its circuitry with every passing second, yet it manages to feel the microscopic vibration of single electrons displaced by a shockwave that originated from the sun a year prior. It digitizes this vibration into a string of ones and zeros, encodes it onto a 20-watt radio beam, and fires it across 24 billion kilometers of expanding space, hitting a frozen satellite dish on Earth with mathematical perfection. This level of engineering borders on the miraculous, but the universe is entirely indifferent to our miracles. The data coming back from the edge of the solar system paints a picture of isolation that is fundamentally horrifying. We celebrate the spacecraft's entry into interstellar space as a final triumph, a crossing of the ultimate finish line. We imagine it has left the solar system completely. This is perhaps the greatest and most comforting misconception modern humans hold about our place in the cosmos. Crossing the heliopause is merely leaving the atmosphere of our neighborhood. It is stepping off the front porch, the actual gravitational boundary of the solar system, the true threshold where the sun's gravitational pull is finally overpowered by the collective gravity of the Milky Way, is so far away that the numbers begin to break the human capacity for conceptualization. Beyond the heliopause, lurking in the pitch-black void, lies a theoretical structure known as the Oort cloud. It is a spherical shell composed of trillions of icy bodies, frozen comets, and ancient planetary fragments left over from the violent accretion of the solar system 4.6 billion years ago. These objects do not emit light. They are dead, silent monoliths orbiting the sun at distances so extreme that a single orbit can take millions of years. The spacecraft is currently traveling at an astonishing velocity of 17 kilometers per second. At this speed, it could cross the entire continental United States in roughly 4 minutes. It has been flying at this relentless pace, without stopping, without slowing down, for nearly half a century. And yet, at 17 kilometers per second, it will not reach the inner edge of the Oort cloud for another 300 years. 3 centuries of flying through absolute darkness just to reach the beginning of the debris field, to traverse the entire thickness of the Oort cloud, to finally punch through the outermost gravitational sphere of the sun and enter the pure, uncontaminated expanse of the galactic void, will take the spacecraft roughly 30,000 years, 30 millennia. Human civilization in its entirety, from the first agricultural settlements in Mesopotamia to the construction of the deep space network, spans perhaps 10,000 years. We have barely scratched the surface of time. The machine we sent into the dark will spend 3 times the total duration of recorded human history just to navigate the icy graveyard of our own star system. It is a timeline that renders human existence mathematically insignificant. But the machine will not be awake to see it. Long before it reaches the frozen edges of the Oort cloud, long before the year 3000 rolls across the calendars of whatever civilization remains on Earth, the final embers of the plutonium will turn to ash. The steady degradation of the thermocouples will drop the electrical current below the absolute minimum threshold required to power the gyroscopes. The computer will initiate its final fault protection algorithms. It will attempt to find a solution to an equation with no remaining variables. It will desperately try to reroute power from instruments that have already been surgically severed. In its final moments of operational life, the telemetry data suggests a terrifyingly quiet sequence of events. The radio transmitter will drop its carrier signal, the faint 20-watt whisper that has connected us to the deepest cosmos will stutter, fragment, and finally flatline. The giant parabolic dishes in California and Madrid will listen with their cryogenic ears, but they will hear only the hissing thermal noise of the Big Bang. Without the gyroscopes constantly correcting the drift, the immense high-gain antenna will slowly lose its lock on a pale blue dot 24 billion kilometers away. The spacecraft will begin to tumble, ever so slightly, rotating blindly into the dark. The heaters that kept the propellant lines liquid will freeze solid. The sensors that tasted the plasma waves will go permanently cold. The machine will transition from an active explorer into a dead, silent monument of human ambition, hurtling blindly into the 30,000-year abyss of the Oort cloud. Yet even as the telemetry dies and the silence becomes absolute, the physical structure of the spacecraft will endure. Out there, in the vacuum, there is no oxygen to rust the aluminum. There is no moisture to corrode the gold plating. There is only the occasional, microscopic abrasion of interstellar dust, wearing down the metal at a rate of mere atoms per century. The sheer emptiness of the space guarantees its physical preservation. It is a tomb built to outlast the Earth itself. As scientists monitor the failing power levels, a profound sense of mourning permeates the control rooms. It is a mourning not just for a machine, but for the loss of a sensory organ. For nearly 50 years, humanity has had an eye looking out from the edge of the abyss. We have felt the magnetic fields twist and break. We have recorded the violent impacts of cosmic rays born in supernovas on the other side of the galaxy. We have touched the physical boundary of our star's influence. But as the power inevitably drains, as the voltage drops millivolt by millivolt, a disturbing realization begins to take shape among the physicists analyzing the final streams of data. The numbers returning from the edge are becoming erratic, not because the instruments are failing, but because the environment itself is behaving in ways that contradict our fundamental models of astrophysics. The magnetic field of the interstellar medium is not aligning as predicted. The density of the plasma is not smoothing out into a uniform fog, but appears to be clumping, tearing, and moving with an energy that should not exist in the silent depths of the void. The machine is dying precisely as it reaches the threshold of an anomaly. The data currently locked in the delayed transmission cycle, taking 22 hours to reach our screens, hints at a structural deformity in the very fabric of the galactic medium. It is as if the spacecraft, in its final suffocating gasps, is brushing against something massive, something entirely unaccounted for in the standard model of cosmology. The mathematical models describing the interaction between the heliopause and the interstellar magnetic field, driven by the equations curl B equals mu 0*J and div B equals 0 are breaking down in the face of the raw, incoming telemetry. We are losing the signal exactly at the moment the dark begins to speak back. We are watching the monitors, completely helpless, bound by the cruel latency of light speed and the relentless decay of a radioactive core. As the final stream of numbers attempts to describe a geometry we do not understand, the silence is closing in, but the data preceding it is screaming. For over half a century, the architectural blueprint of the interstellar medium was a settled matter, a comforting mathematical certainty sketched out on blackboards in Cambridge, Princeton, and Pasadena. Astrophysicists had constructed a highly elegant, highly sterile model of what lay beyond the sun's influence. We imagined the space between the stars as a tranquil, isotropic void, a quiet ocean, vast and undisturbed, where the magnetic fields of the Milky Way drifted in parallel, predictable lines, and the ancient plasma rested in a state of thermodynamic equilibrium. Our terrestrial intuition, desperate for order in the dark, had essentially projected the calm of an empty room onto the most chaotic environment in the universe. We assumed that once we breached the turbulent, boiling boundary of the heliosphere, we would simply sail out into a mathematically smooth, frictionless dark. But the universe is under no obligation to respect our equations. The data currently bleeding through the deep space network is not just anomalous, it is structurally offensive to our fundamental understanding of galactic mechanics. To comprehend the magnitude of this scientific crisis, we must look closely at the specific sensory organ on the spacecraft that is triggering this alarm, the fluxgate magnetometer. Unlike the cameras that were permanently blinded decades ago, or the infrared sensors that were systematically frozen to conserve power, the magnetometer is a primitive, brutally robust piece of technology. It does not look for light, it feels for invisible tension. Mounted at the very end of a 13-meter-long fiberglass boom, extended as far away from the electromagnetic interference of the spacecraft's own decaying nuclear heart as physically possible, this instrument measures the strength and direction of magnetic fields. It operates on a microscopic scale, sensing magnetic forces hundreds of thousands of times weaker than the pull of a cheap magnet on your refrigerator. It is designed to map the invisible scaffolding of the void. According to every accepted textbook on magnetohydrodynamics, crossing the heliopause should have been a clean, definitive event. The theoretical physics were clear. Inside the solar bubble, the magnetic field is generated by the sun. It is a solar field. Outside the bubble, the magnetic field belongs to the galaxy itself. These are two entirely different physical regimes, born from different sources, pointing in different directions. The exact prediction was that when the spacecraft finally pierced the membrane of the helios, the magnetometer would register a sudden, sharp, and dramatic shift in the angle of the magnetic field. It was supposed to be the ultimate compass needle, swinging wildly as we left the magnetic territory of our star and entered the magnetic territory of the Milky Way. That is not what happened. When the particle detectors screamed that we had crossed the boundary, when the deluge of solar plasma abruptly vanished and the heavy, lethal bombardment of galactic cosmic rays spiked to terrifying levels, the magnetic field did something impossible. It did not shift. It did not change direction. The compass needle remained frozen, pointing in the exact same orientation it had been pointing while inside the solar system. The only difference was that the intensity of the field suddenly compressed and intensified. This is the interstellar flux transfer paradox. It is a contradiction so profound that it initially led engineers to believe the magnetometer was failing, succumbing to the lethal cold or the relentless radiation. But the telemetry was verified over and over again through the agonizing 22-hour delay of light speed. The instrument was functioning perfectly. It was reality that was broken. To understand why this is horrifying to a theoretical physicist, you have to understand the behavior of plasma. In the vacuum of space, magnetic fields and ionized gases are not separate entities. They are inextricably bound together by the laws of electromagnetism, governed by a principle known as Alfvén's theorem of flux freezing, formulated by Hans Alfvén. This theorem dictates that in a highly conductive fluid like the plasma of the interstellar medium, magnetic field lines are literally frozen into the fluid itself. Imagine the magnetic field lines as unbreakable strings, and the plasma as incredibly thick, viscous honey. Wherever the honey flows, the strings are dragged violently along with it. If you twist the honey, the strings twist. If you compress the honey, the strings bunch together. Mathematically, this relentless coupling is described by the magnetic induction equation, expressed as dB dt, cool 5D B más et por d L al cuadrado B. In the ideal collisionless plasma of deep space, the second term, representing magnetic diffusion, vanishes. The fluid and the field become one indistinguishable ghost. Therefore, if the spacecraft had truly left the solar plasma and entered the galactic plasma, the magnetic strings embedded in that new alien honey should have been oriented differently. The fact that they were not, the fact that the galactic magnetic field perfectly aligned with the solar magnetic field implies a structural impossibility. It suggests that the boundary between our star and the rest of the galaxy is not a simple shoreline. It is a massive, complex, and highly active membrane where the galaxy is somehow interacting with our solar system in a way that defies the fundamental equations of fluid dynamics. Let us deepen this. Look at the sheer absurdity of the alignment. The odds of the Milky Way's vast ancient magnetic field naturally lining up perfectly with the localized, fluctuating magnetic field of our specific, unremarkable star are vanishingly small. It is the equivalent of dropping a compass in the middle of a roaring hurricane and finding that the needle points exactly, perfectly, unyieldingly, true north, without a millimeter of deviation. This forces us into a deeply uncomfortable corner of theoretical physics. If it is not a coincidence, then something physical is forcing the alignment. Something is actively bending the galactic magnetic field to wrap around our heliosphere. This brings us to the concept of the stagnation region or the magnetic depletion zone. The data implies that the solar system is not just drifting passively through the galaxy. It is acting like a colossal, blunt object plowing through a supersonic medium. As the heliosphere smashes into the interstellar plasma, it forces the galactic magnetic field lines to drape over it, to stretch and compress around the bubble, like water wrapping around a stone in a fast-flowing river. But a river is a poor analogy, because a river implies a smooth, laminar flow. The telemetry, whispering through the deep space network, paints a picture of extreme violence. As the spacecraft pushes deeper into this alien space, the temperature readings are returning numbers that seem entirely contradictory to the concept of a freezing void. We are detecting regions where the kinetic temperature of the plasma spikes to tens of thousands of degrees. This is a concept that aggressively violates our daily intuition. How can something be tens of thousands of degrees hot in an environment that is a fraction of a degree above absolute zero? We must differentiate between thermal heat, the kind that burns your skin, and kinetic temperature. In the unimaginably sparse vacuum of the interstellar medium, temperature is not a measure of how hot the space feels. It is a measure of how fast the individual particles are moving. If you were to stick your bare hand out into this region of space, you would instantly freeze solid, because there are not enough particles hitting your skin to transfer any meaningful thermal energy. But the individual particles that are there are screaming through the void at terrifying velocities. The sheer kinetic energy of these isolated protons and electrons is astronomical. The spacecraft is effectively sailing into a cosmic pressure cooker. The data suggests we have hit a wall of fire. As the solar wind collides with the interstellar medium, particles are caught in the magnetic turbulence, bouncing back and forth across the shockwave, gaining immense velocity with each collision. This is the mechanism of Fermi acceleration. The particles are being weaponized by the boundary layer itself, turned into high-energy cosmic radiation, and our dying machine is flying directly through the thickest part of this invisible radioactive storm. Let us examine the raw numbers, the cold, unyielding metrics of the void. Inside the heliosphere, the magnetic field strength is measured in nanoteslas. Near the Earth, the solar magnetic field hovers around 5 to 10 nanoteslas. As you move outward, expanding the sphere of influence, the strength drops off precipitously. By the time the spacecraft reached the termination shock, the inner boundary where the solar wind suddenly decelerates below the speed of sound, the field had dropped to a fraction of a nanotesla. We expected that once outside, in the true interstellar medium, the galactic magnetic field would be incredibly weak, perhaps 0.1 or 0.2 nanoteslas, and oriented at a severe angle to the solar plane. Instead, the magnetometer recorded a sustained, powerful field of nearly half a nanotesla, perfectly aligned with the solar field. To a layperson, half a nanotesla sounds pathetic. To a plasma physicist, it is a deafening roar. It means the energy density of the magnetic field in the local interstellar medium is far higher than anyone ever calculated. This elevated energy density requires a source. It requires a mechanism of compression. If we return to the equations of fluid dynamics, specifically the conservation of momentum in a magnetized plasma, we find that the total pressure is the sum of the thermal pressure of the particles and the magnetic pressure, defined by P underscore total equals N kilobyte asterisk T plus B2 per 2 asterisk mu 0. If the magnetic pressure is significantly higher than expected, it means the entire region of space is under immense, unseen physical stress. The galaxy is crushing against the solar bubble, and the bubble is fighting back, creating a localized zone of extreme tension. The sheer scale of this magnetic barrier presents an existential problem for the future of our species. We have spent decades dreaming of interstellar travel, designing theoretical propulsion systems from solar sails to antimatter drives, believing that once we cleared the gravity well of our star, the path to Alpha Centauri would be an open, empty highway. But the dying telemetry of our probe is rewriting the map. The space immediately surrounding our solar system is not empty. It is a turbulent, highly magnetized, heavily irradiated boundary layer. It is a moat, and we have no idea how deep it is. The mathematical models we relied upon have completely collapsed under the weight of empirical data. The equations that govern the macrostructure of the galaxy, the tensor calculations of magnetohydrodynamic stress defined by T equals 1, mu 0, asterisk B, 0.5, asterisk B, A, asterisk I, cannot resolve the localized chaos we are observing. We are witnessing the breakdown of our own physics in real time, but with a 22-hour delay. Imagine the sheer psychological toll on the engineers and physicists sitting in windowless rooms on Earth, staring at the telemetry screens. They are watching the slow, agonizing death of a machine they built with their own hands. And in its final moments, it is telling them that the universe is fundamentally more hostile, more complex, and more terrifying than they ever dared to calculate. They cannot send a repair drone. They cannot adjust the sensors. They are trapped behind the speed of light, watching a slow-motion unraveling of their life's work. Every time a massive coronal mass ejection erupts from the sun, a shockwave propagates outward, taking roughly 400 days to reach the spacecraft. When the shockwave hits the interstellar plasma, it causes the local magnetic field to ring like a bell. The plasma wave subsystem, slowly starving of power, manages to capture these frequencies, but the pitch of the ringing is constantly changing, suggesting the density of the interstellar medium is not uniform. It is clumping together in massive, invisible clouds. We are not sailing into a clear ocean. We are navigating a minefield of dense plasma structures, some spanning billions of kilometers, and we are doing it entirely blind. And this tension is not merely theoretical. It is actively destroying the spacecraft's cognitive functions. Because the magnetic field is behaving erratically, the shielding effect of the heliosphere is compromised in unpredictable ways. The spacecraft is now fully exposed to the raw, unfiltered fury of galactic cosmic rays. These are not rays of light. They are atomic nucleoprotons, helium, and heavier elements stripped of their electrons and accelerated to near the speed of light by the shock waves of ancient supernovas. When one of these relativistic particles strikes the spacecraft's aging solid-state memory, it does not just pass through harmlessly. It deposits a microscopic trail of ionized plasma directly inside the silicon chips. This ionizing energy can physically flip a microscopic transistor from a 0 to a 1 or a 1 to a 0. In aerospace engineering, this is known as a single event upset. For decades, the software engineers at JPL have been writing redundant code, implementing complex error-correcting algorithms to hunt down these corrupted bits and rewrite them before they can crash the main flight computer. But as the power dies, the computational resources required to run these constant self-diagnostics are becoming scarce. The machine is losing its mind, bit by bit, struck by the invisible shrapnel of dead stars. The engineers must decide which corrupted memories to save and which to abandon to the void. The paradox is that the very environment the spacecraft was built to study is actively erasing its ability to comprehend it. We are left staring at a brutal, inescapable truth. The magnetic field is a cage. The temperature is a wall of invisible fire. The data is a paradox that contradicts our most deeply held laws of physics. We are mapping an anomaly that spans billions of kilometers using a machine that is freezing to death, powered by a dying atomic ember communicating across a 22-hour void. The math is breaking down. The models are failing. And as the telemetry slowly degrades, painting a picture of a chaotic, violent, and utterly incomprehensible environment, the data slowly bleeding from the mutilated memory banks of our distant probe forces us to confront a terrifying paradigm shift. We have spent centuries looking up at the night sky, charting the constellations, and projecting our ambitions onto the silent canvas of the Milky Way. We assumed the dark was simply empty space, a passive, frictionless medium waiting to be crossed. but the violent magnetic anomalies and the wall of kinetic fire discovered at the edge of our solar system reveal a deeply unsettling truth. We are not sailors standing on the shore of a calm cosmic ocean, ready to launch our vessels into the deep. We are inhabitants of a pressurized deep-sea sphere, floating blindly through an abyssal trench, entirely unaware of the crushing, lethal forces just outside the glass. The heliosphere is not merely a boundary or a line on a map. It is a quarantine zone. For 4.5 billion years, the turbulent magnetic bubble generated by our sun has acted as a colossal filtration system, shielding the inner planets from the true, unfiltered brutality of the galactic environment. Life on Earth did not evolve to survive the universe. It evolved to survive the highly specific, incredibly sheltered microclimate of the solar wind. The implications of this magnetic cage extend far beyond the slow, agonizing death of a single machine. They strike at the very heart of our long-term survival and our arrogant dreams of a multistellar future. When we hypothesize about interstellar travel, about generation ships or warp drives, we imagine navigating a quiet void, but the dying telemetry of the probe confirms that the interstellar medium immediately outside our solar system is saturated with relativistic shrapnel. The galactic cosmic rays bombarding the spacecraft are not uniform. They are channeled, compressed, and accelerated by the twisted magnetic scaffolding of the boundary layer. To cross this threshold, a physical vessel would not just need immense propulsion. It would need to survive a continuous omnidirectional nuclear detonation. Let us apply the cold mathematics of radiation physics to biological tissue. The energy of these incoming atomic nuclei is measured in giga-electron volts. When a particle carrying that much kinetic energy strikes the hull of a spacecraft, it does not simply stop. It shatters the atoms of the metal shielding, creating a secondary shower of lethal radiation neutrons, muons, and gamma rays that floods the interior. This is the physical mechanism of spallation. It is a subatomic shotgun blast. Inside the protective womb of the Earth's atmosphere and magnetic field, the annual radiation dose for a human is roughly 3 millisieverts. Out there, in the chaotic magnetic surf of the heliopause, a human body would absorb hundreds of millisieverts in a matter of days. The complex, fragile geometry of our DNA would be systematically shredded. The microscopic double helices would suffer double strand breaks at a rate far exceeding the biological capacity for cellular repair. It is a silent, invisible fire that burns the blueprint of life from the inside out. We are discovering that the open road to the stars is paved with a highly localized, highly concentrated zone of biological annihilation. The solar system is a walled garden, but the walls are made of ionizing radiation, and they are designed to keep us exactly where we are. But the consequences of this turbulent boundary layer transcend the physical limitations of space travel. The most profound and deeply disturbing revelation, hidden within the final whispers of the machine, is that our perception of reality itself has been fundamentally distorted. Every photon of starlight, every radio wave emitted by a distant pulsar, every microwave whisper from the dawn of the Big Bang that has ever reached a telescope on Earth has had to pass through this localized magnetic storm. We have built our entire understanding of astrophysics, cosmology, and the structure of the universe from inside a funhouse mirror. Consider the physics of polarized light. When electromagnetic radiation travels through a magnetized plasma, the plane of its polarization rotates. This phenomenon is known as Faraday rotation. defined by the strict mathematical relationship beta equals rm asterisk lambda a, where the rotation angle is dictated by the wavelength of the light and a crucial variable called the rotation measure. For decades, astrophysicists have used the rotation measure of distant galaxies to map the immense magnetic fields of the Milky Way. We implicitly assumed the local space around our solar system was a negligible variable in these equations, a clear window pane that did not alter the view. But the magnetometer readings screaming from the edge of the void have shattered that assumption. If the local magnetic field is fiercely compressed, violently twisted, and tens of times stronger than anticipated, then the window is not clear. It is warped, thick, and highly refracted. The data implies that our maps of the galactic magnetic field, the very navigational charts we use to understand the mechanics of the Milky Way, are contaminated by the invisible distortion of our own solar bubble. We have been trying to study the exact shape of a snowflake while submerged in a boiling river. How much of the cosmos we observe is real, and how much is merely a localized optical illusion generated by the turbulent wake of our own star plowing through the void? We may have to rewrite the fundamental constants of our local galactic neighborhood, not because the universe changed, but because we finally realized we are wearing a blindfold. This distortion forces a terrifying reevaluation of time and our place within the grander celestial mechanics. The solar system is not stationary. We are currently orbiting the supermassive black hole at the center of the galaxy at a velocity of over 800,000 kilometers per hour. As we orbit, the sun drags the entire heliosphere with it, carving a path through the interstellar medium. But the interstellar medium is not uniform. The galaxy has weather. It has dense clouds of ancient gas, carved out by the shock waves of dead stars and the violent birth of new ones. Right now, our solar system is moving through an environment astrophysicists call the local interstellar cloud, a relatively wispy, warm mist of hydrogen that stretches for roughly 30 light-years. But the erratic plasma frequencies recorded by the dying probe suggest that the edge of this cloud is approaching faster than our models predicted. The density of the void is fundamentally changing. As the spacecraft suffocates in the dark, it is acting as a tripwire, alerting us to a shift in the galactic geography that we cannot see with our optical telescopes. This is not a matter of abstract cosmology. It is a matter of long-term planetary survival. The size and strength of our protective magnetic cage, the heliosphere, is entirely dependent on a delicate, ongoing balance of thermodynamic pressure. The dynamic pressure of the solar wind pushes outward, while the pressure of the interstellar medium pushes inward. If our solar system plows into a significantly denser region of the galaxy, a thick, cold cloud of interstellar dust and gas, which are scattered completely randomly throughout the Milky Way, their inward pressure will violently overpower the solar wind. The protective bubble will shrink. It could compress so severely that the heliopause is pushed all the way down to the orbit of Jupiter, or even Mars. If that happens, the Earth will be entirely stripped of its cosmic shielding. The wall of fire, the intense concentration of kinetic particles and deadly galactic cosmic rays that our probe is currently fighting, would wash directly over our pale blue dot. It would alter the chemistry of our atmosphere, severely deplete the ozone layer, and trigger a cascade of biological extinctions. Our climate, our evolution, and our future are entirely at the mercy of the invisible galactic, whether we are blindly rushing toward at hundreds of thousands of kilometers per hour. We sent a machine into the dark to find answers, but instead, It has illuminated the terrifying fragility of our existence. It has shown us that the quiet, stable universe we observe from our backyards is a localized, temporary anomaly. The reality of the cosmos is one of overwhelming hostility, governed by forces and scales that reduce human history to a meaningless rounding error in a vast thermodynamic equation. The fading pulse of the spacecraft is not just the death rattle of a robot, it is the slow closing of a heavy door. We are losing the only sensory nerve we have ever managed to extend into the true, chaotic reality of the galaxy. When the final milliwatt of power bleeds away from the decaying plutonium, when the transmitter falls permanently silent, we will be entirely blind again. Trapped behind a wall of magnetic fire, isolated in the dark, we will have no way to measure the density of the encroaching clouds, no way to monitor the shifting tension of the magnetic cage that keeps us alive. We are passengers on a fragile, pressurized lifeboat, sailing through an invisible, radioactive minefield, and the only flashlight we possess is flickering out. As the telemetry degrades into static, painting a picture of an environment that actively resists our presence, we are left to confront the horrific, unyielding geometry of our own confinement. When the final command is sent, and the last fragmented strings of telemetry finally dissolve into the static hiss of the cosmic microwave background, we will not hear a crash. There will be no explosive finale, no dramatic rupture to mark the end of humanity's greatest physical achievement. The universe does not mourn the extinguishing of a light. The transition from an active, perceiving machine into a dead, blind monolith will happen in absolute, suffocating silence. For a brief, microscopic fraction of galactic time, a fleeting geological second, we managed to cast a 20-watt whisper against the deafening roar of the Milky Way. We built a fragile mechanical ghost out of aluminum and silicon, fueled it with the decaying ashes of an unstable atom, and threw it into an ocean we fundamentally do not understand. And for half a century, it obeyed. It spoke to us. It told us the horrific shape of the dark. It mapped the invisible, turbulent walls of our own magnetic cage. It felt the violent breath of the galaxy, but the physics of the void are absolute. The mathematics of radioactive decay cannot be stalled, and the geometry of expanding distance cannot be negotiated with. The fire is going out. Eventually, as the voltage drops below the threshold of the gyroscopes, the high-gain antenna will begin to drift. It will slip, perhaps just a fraction of a single degree, away from the pale blue dot it has stared at for decades. In that precise, microscopic moment of misalignment, the connection will be severed permanently. The spacecraft will instantly transform into an artifact. It will become a silent, freezing tomb for a species that was terrified of the dark and desperate to be heard. It will carry our golden record, our engraved greetings, and our coordinates deeper into the abyssal night of the Oort cloud. But the hands that built it, the eyes that watched the telemetry, and the civilizations that funded its journey will have long since turned to dust. It will sail onward, in total blindness, for 30,000 years, just to clear the icy debris of our star. It will drift for millions of years more through the twisted, irradiated, magnetic storms of the interstellar medium. It will physically outlive the mountains of Earth. It will outlive the boiling away of our oceans. It will likely outlive the very memory of humanity itself. But it will never see, and it will never speak again. We are left standing on the fragile shore of a small, rocky island, enveloped in a turbulent, violent, and utterly indifferent sea. We have measured the crushing weight of the water. we have mapped the lethal currents. We have realized that the celestial horizon is not an open door inviting us outward, but a terrifying, shifting boundary that actively resists our existence. The comforting illusion of an empty, passive universe has been entirely dismantled by a dying probe. The dark is heavy, it is active, it is overwhelmingly hostile. The signal is fading. The geometry is expanding. The wall of fire remains. Listen to the absolute silence that follows. It is not an empty space waiting to be conquered. It is the natural, permanent, and final state of the cosmos. A darkness so incredibly vast and so entirely complete that the very memory of our fragile light will simply be swallowed whole.